biggest enemy comes in, because when you straight away dump there into your silo, there's a lot of dust. So we have to capture that dust, and we be sure that we capture the dust and take it away from the main area, and be sure that we treat it later on so that it doesn't go into the environment and have an environmental hazard. So this is called a vacuum, because your motive power is here behind you, so all this system is under vacuum. That's why it's called a vacuum system. Then we have a pressure system here, where you have the motive power is here, so you pressurize it and then take it to your silo or storage area, and then this is your culprit here, the dust collection, and then you get out to the environment. And this is a combination of the two above, which is also used. And this part is the vacuum side, and this is the pressure side. So you can see both of them are working in conjunction with each other. What we can do with it, we can unload, like if you have a barge or railroad car or a truck, you come out, you separate your dust from here, get into your storage, and go into your process area, and you go and start doing the process work. We can store it, which you saw it here, that it can store. We can reclaim. Once you have stored equipment, stored material, and you want to take it in the process, then what you do, you take it out from here and go into your process streams. We got bulk loading, where you are loading, this is our product, like fertilizer, or polyethylene, polypropylene, all those petrochemical jobs, which we did at Pasadena. I don't know whether somebody was there a couple of years ago, and we did a very big job for polyethylene and polypropylene. So we get involved with all this handling system, and when your product is out, this bulk loading, then your product has to be loaded into a railroad car or a barge or in a ship or in a truck. So all those systems which you see, what you do here with pneumatic can be done by vacuum, pressure, and also by a combination of the two systems. And that's the way the pneumatic system works. I'll give you some very practical examples. These are the old slides I was talking about. So bear with me for a little while. And this I had to find from a box, but this gives you a very good picture of what happens in a process. This is a railroad car. We get the material, we separate the dust out here, we go down, and we can split it three ways. One goes straight into a conveyor to a process, another goes into this storage silo, third one goes here. Now, we can also pick up from here and bring it back, and also go into process stream here by using this vacuum system, because this is your motive power here. This gives you an example of what an actual plant will look like. You can see these huge silos here, and this part here is your triple diverter or a distributor. It goes three different ways. So this system was exactly for this plant, which was built by one of our ex-companies. Okay, this is another system which I'll go a little quickly and get it over with. There we are showing that we can do number of ways. You can see how many ways we can split, because the pneumatic system is very flexible. You move it so many different ways, and it works. And this is your starting point, where you got your material and then split it. And this is an actual plant which was built on this basis. You can see the plant, how all this storage is. Now here there is an interesting point which I made before, that everything first you go up and then use your gravity. See all these chutes which are using gravity. There's no power required. It just goes down into your silos, and then it goes down further down into process. Everywhere we use our friend gravity all the time. This is one more. I just don't want to go too much into it, but it gives you another configuration of how we put it all together and how it all comes together. Okay, now we come to the solid transport equipment. These are the conveyors, and many of you know, at least you might have seen a conveyor somewhere. But most important, most used conveyor is this belt conveyor, which is simple belt, which is an endless belt, and you have the material going through that conveyor. You have the motors, you got conveyors, you got all the structural steel there. The other type of conveyor you might see in a powder plant or a catalyst plant would be a screw conveyor, which is handling more of a powder, because this is a screw which brings from A to B and dumps it down to the next process equipment. Then there's another conveyor we use quite a bit, is the vibrating conveyor, which is vibrating and pushing the material from there to there to there to there to the discharge. And there is a fourth kind which you might see, maybe if somebody has seen a brewery or a packaging plant, where you have this conveyor here, where you can see the boxes being conveyed and gone into storage and of course going off to the market. Okay, that tells us something more about the conveyors. And this is an interesting picture. I'll bring up one or two good points about conveying. See, if you look at the conveyor, this is a belt conveyor which goes all the way into a terrain, which you can see it goes straight up there. One thing very interesting about material handling, when you design a conveyor, there's a lot of real estate required, because you can't, in a piping, in a refinery, you have a pipe going this way, you can go that way, you can go that way, you can go there, you can go there. But when it comes to material handling, you go just straight. You can't turn. Only time when you can turn, or if you have to turn, you have to take it out of that conveyor, dump into a second conveyor which goes this way. If this conveyor is going that way, you want to go there, you come out here, you drop it here, and then you go this way again. So there's a lot of real estate and planning by piping before they can put a conveyor together. Other thing which is interesting here, you can see, is an endless belt. It has a concave curve and a convex curve here. You can see there's a convex. So it is very flexible as far as where you can go and how you can go. But this gives you a good example of it can go through miles and miles and miles and miles, and you can design a system for this. Is more used into minerals and mining area. This one here, I did it to show you something more about how it is supported. You can see there's a conveyor there, and you need support, so the structural people get involved with us. We got a walkway, there's all structure. We get OSHA involved because these walkways are all OSHA requirements. We have the belt here, and then we have the drives, of course, the electrical people and the controls people, because a material handling system, when you start the system, there has to be interlocks. You start this conveyor here, and a second conveyor here, and a third here. If this conveyor is leading, if you stop that conveyor, you better stop all these conveyors before them right away, because otherwise you're going to get all this huge amount of material on the ground and a lot of dust and environmental hazard right away. So it's all interlocks, a lot of controls and instrument people get involved with material handling. This one, I just wanted to show you something interesting here, that you could go into a tunnel. This is for rotary screens, but this actually is a similar situation where you go through the tunnels. You might see conveyors going through big tunnels across the land. You know, it could be going for miles and miles, and you have a big mountain there you have to go through. How do? You don't want to go up and spend so much money on your power. You go through tunnels, and you can go through just like rail car, trucks, cars. Our cars go through the same way the conveyors go through the same thing. Okay, the next thing which you see in transport equipment is the feeders. These are short conveyors, basically, similar to what we saw before. And they are like this: a belt feeder, and then there is a vibrating feeder, the screw feeder, and the vibrating. So they are smaller, which feeds a very nice rhythmic way of loading your systems. And so those are the feeders. Then we have elevators, which we talked about a little bit, but this is where you have, in a plant, you want to go up there, but you don't have room. Now what do you do? How do you do? You conveyor, as I told you, they go straight like that. You can't reach there. You want to reach right here. Then you use these elevators, and these are the elevators. There are a number of types we use. This is the most common one, which is used being that it uses centrifugal force, and it just dumps material from here upstairs and dumps it there. Then there are other kinds here, which I don't want to go too much in detail. This is more of gravity type, and this is another one which is pivoting type. So you pivot the buckets. These are all buckets, and this is a chainless, a chain which runs up and down all the way. And that gives you the idea of those conveyors. Well, we come to the solid storage equipment. I told you before that storage becomes one of the big issues in material handling, because you have to handle a lot of bulk, huge amount of storage. And so this is a good example here of two concepts which I told you about. That is the elevator, which brings, you can see you don't need big real estate. You just bring it from bottom to up. Then these are the chutes which takes care of the material going down and using gravity. You can see the gravity being used here. And also when you discharge here, you're using gravity, so there's no power used there at all. There might be power for some controls, but basically it just uses our friend gravity. And these angles are very, very important in material handling design. Depending on the angle of repose, which we talked about earlier, that angle of repose is a natural angle of any material. You just drop some powder when you go home, you just drop some sugar on a dish or a salt, you will see that angle is different in all of them. And that is a very important factor in any material handling design. That angle becomes very, very critical for us to design any system. Okay, now this one, if you see, I want to give you some example of different material we use for. This is a steel bin. This was one of the plants we designed. This is a steel bin. It's an old plant we did a long time ago. And this one gives some of the different supports we use for your friends from vessels would recognize this very well. There are different kinds of supports we provide for the silos here. You can see this here or here or there or there. All different kinds of supports we have to provide depending on the design, what design we are having, and how much space we have, and what kind of center of gravity we have. This is another plant we designed. This is for the polyethylene plant, which is a petrochem plant, which we have not done at Worley Parsons, but we have done at Parsons in Heritage, which is in Pasadena, in my company X, where I work for. We designed, and these are used for petrochem and petrochemical type of plants, and you can see they are made of aluminum. So it's a different material we can use, steel, aluminum, and there is yet another one which we use is concrete. We have huge silos we have designed. This is being done today as we speak. We are going to use the same concept for our North American job, the sulfur recovery job here in 222. The whole group is there, North American oil sands. And we are going to be using, and we are going to be forming sulfur into solids and using. This is an existing plant for Shell. And Shell, these are giant silos, and these are concrete. So this is a third way we can build the silos. And just to give you the flavor of how many different things we can do with material handling and how many things, how wide it goes. It can just go on and on and on. And this also gives you some idea of the conveyors. You can see the conveyors here, and then you're dropping it here, and you're fitting the rail car. This is a railway track here. And then there are side conveyors for reclaim. This is the plant which is making the solid sulfur. It comes up on a conveyor and dumps it into the silo, and we store it there. Till the railway train is available, we have to store a huge amount of sulfur. So we have to build huge sulfur storage areas. Okay, this gives you some of the quick idea of how we reclaim from big, just giant silos we have. And there are so many different ways of reclaiming your solids back. Okay, this is another view of storage. We can store in those huge silos we talked about, but we have sometimes so much of bulk, huge amount of solids. So we go inside a building. We have to store, because there are two or three main reasons. One, of course, we have huge amounts, so the silos become so many and so huge. Sometimes the other reason is if you are near a town, you are a city municipality, or where environmentalists won't allow you to dump any solids outside. You have to cover it completely. The third part is of course the weather. You might be in Canada, you might be in northern part of the country, and there's a lot of rain and snow and all, and you can't keep your material inside, so we go indoors. So this is an inside building storage. So we have huge buildings. So you can see the plant versus the storage area is huge amount we need. Okay, this one gives you another shot at two different things here. This one shows you the outside storage, because these are bulk, but these are remote plants, so that not too many people and environmentalists don't bother you, because there's not, but we still have to contain the dust. The interesting part about this, you can see here, this is the angle of repose of this material here, and this is the angle of repose. Angle of repose is the angle this natural angle which happens when you drop it naturally by gravity with the horizontal. So you can see this material has a different angle than this material. This is a little steeper, and that is the characteristic of that material. So anytime when your solids you're handling, you have to worry about what angle is the natural angle of that particular material. And this next picture gives you inside of the one which we saw there. This is the inside storage, and what happens, you go to conveyor all the way up there, you drop your material, and then you start filling your storage, and then when you reclaim by front-end loaders, and then go out and go for shipment or wherever you want to go next. Okay, this gives a general picture of our friends in controls. People are not here, but I kept it for them because I wanted to show them how many controls we have in a material handling system. We have controllers everywhere you see here are controllers. We have a screw conveyor, which we talked about. We got a bucket elevator here. We talked about silos storage. We got another silo here. We got another conveyor here, another belt conveyor. Everywhere you see these signs, they are all instruments. There are so many control instruments which are given some details here, but they are involved in. So we work very closely with controls people to put the right instruments there and right controls there. By the way, you can ask me questions anytime. Don't worry. I want to make it very informal. So if we ask questions, don't worry. We'll go faster later. So it doesn't bother me. Okay, this is the size reduction. And this is mostly used for mining and all that, and I'll go quick on this one. We don't use too much of it, but these are mining. And we got different kinds of crushers. So we have big, huge mining rocks and all that, we crush them, and then we got another kind of crusher and third kind of form. So they're all different kinds for different material, and there's a selection guide here so we can pick up what industry we are working with. Okay, this is an interesting one because we will have this eventually. You might get involved with this. This is an extruder. So when we get a petrochemical, once we finish the refining and go into petrochem plants and other type of products, and we might get projects, we did that in Pasadena. This is the one where you have an extruder which has got an interesting screw here which extrudes from petrochemical crystals, and then we make from the liquid side we go into solid side here, where you have these double screws, they are rotating, and you squeeze it here just like spaghetti, and then you cut at the end, you start cutting it, and that becomes your little product which you use for shipping, and then you use it for all the plastic bags and polyethylene, polypropylene, all kinds of bags, which this plant we have designed at Pasadena, and that was for Saudi Arabia, and we did that. Okay, this is showing you the extruder, some more details. You can see the size of the extruder. This gives you an idea of the size. They become quite big, and this is one machine only. Everything is automated. There is nothing, you don't do anything, it's just automatic. Okay, this is pelletizer, and the pelletizing is when we have powders. It becomes harder and harder. Powders are hard because we got dust. So here we pelletize so that we firm it up again. So this is enlargement. Instead of powder, we make it bigger so we can handle it better. And there are so many advantages of pelleting, and this gives you some examples. Some of the advantages, I'm not going to go too much into it because we are really running out of time. Okay, this is a dryer. Just quickly, material enters here, the hot gas is here, and you dry. By the time you come out, you got the dry product, and the gases come out here. This is an actual plant where you can see the dryer. This is where you arrest your dust so that it doesn't pollute the environment. This is another way of drying and dewatering. So you're using centrifugal force, and you can see water coming out and the dry product coming out. These are the projects we might get if we get more active in some of the areas. Polystyrene, polyethylene, nylon, and polyethylene again here. And you can see there are two kinds of polyethylene. So whatever the process comes up with, we might have this kind of polyethylene, or we might have this kind. This is black or white. And all this is solids. We have to handle them. And there's a huge amount of handling system for these products, which we might get involved very shortly. This is another thing where you are mixing, how you mix the products from this screw here, and it just takes it up and down. It just goes up and down, and you're mixing the product. Same way here, you can see the screw conveyor here. It just mixes the powders, and these are some other arrangements of mixing. Okay, this is another blender where, if you look at this slide here, we have coal and coke. Coke we are involved with. And if you get coke and we are shipping it to a plant for power generation, we get coke from different stratas, different mines, or different refineries, sorry. And then you blend it by first stacking up and then cutting a cross-section through, so we get all kinds of product, homogeneous product to go into the plant, into the power plant. This is weighing and packaging. We talked about it, but I'll just give you a quick review of that. We've got all kinds of scales we have to use. This is the truck scale, and this is all you can see, the big truck, and these are the platform scale. We also another view of the different scales which we have to use. This is a railroad. I think it's a railroad, yeah, or a truck. It's a railroad one. So different. You can see the giant silos where we have storage of product, and then you got trucks coming underneath, and they are weighed, and then the trucks go out, and your money comes from weighing. And once you weigh, you know how much you have shipped. Otherwise, you won't know how much to charge to your client. So weighing becomes the last part of the project, where we want to be sure that we have a right weighing system to give the client the right amount of product we need to give them, and that's where our money comes from, the client's money, I mean. Okay, this gives you an idea of some of the, how do you weigh in a conveyor. There's a weigh scale, which is while your product is moving on a conveyor, we can weigh it, we can convert it, we have a tachometer, we integrate it, we can totalize it, we can do all kinds of configurations which you see here. This is an interesting one where we blend different products here, but then you have to weigh, and you want to be sure that you get the right blend of final product which goes into the market. Here we are showing a mill, but you could be going to the market. Here is the interesting one where there's solids here and the liquid coming here, and you have to proportion whatever product you are making here. You have to get this and this and this integrated into one system where you have these belt scales coming in. This gives you some of the load cells which we use in our different platforms for weighing platforms. This is the oops, I think I skipped that. This is the weighing system which gives you the total picture of weighing, where you have the product coming in here and you fill the bags. You could be using a pelletizing or polyethylene, polyester, ethylene, polypropylene, sorry, fertilizer, sulfur, whatever you're selling to the market. You just bag them and sew them, and this is ready to go to the market. But this has a whole system, so you can see we buy the whole system. So there's every kind of thing. We've got the motors involved, there are controls involved, there are silos involved, and all kinds of stuff. This is a separation part, which is cyclone. I think many process people know about cyclones. So this is where you separate by centrifugal force. You bring the heavy slurry here, and the light slurry goes that way. This is our friend, which helps us in combating our environment problems. This is a dust collector. We get the dust here, this fully loaded dust. We just collect it in bags here and get the product out here. And the dust is collected, and then the clean air goes out. So this is our big friend, which is a dust collector. You see in many places, you see every time when you have to handle dust, and you have a back filter which helps you. This is another view of the filter and how you clean those bags and all. I don't want to go into too much detail because, as I said, I don't want to make you a material handling engineers, but then you have to backflow the air so that you clean these bags, and that goes down there, and it goes down from the rotary valve and into collection system. These are other things we use in material handling, the gates. Probably you might have heard that gates are there, and we have all different kinds of gates we use. And these are the diverters we use when you want to divert the flow going one way or the other, or if you want to bifurcate, you want to two streams, whatever, you use all those type of equipment. And there's another diverter, another design, but it's a very precision type. This is a valve, iris valve, and just like your camera, this is your iris valve. What it does is, oops, sorry, I missed that one. This I wanted to make a point here for you. When you go into an operating plant and you want to control the flow of solids, here you can see it is very trickling, small flow. This is big flow. That's where they use the iris valve, so you can control the flow. This is an iris valve, the way it looks, and what are the different components. This is the way it works. You can see it. The material is here. There is a fixed ring, another fixed ring, and here we have a flexible material which could be either cloth or fabric or plastic or whatever, and then it flows down. And this is the last slide for this section anyway. This gives you the idea of when you are loading a truck, loading any vehicle, it could be a barge, it could be a ship, whatever, you want to control the dust. So there are retractable chutes which go down here so we don't have any dust, and you collect the dust back here, take it back to the silo. And this ends our part, which is, I think we caught up with the time. Next segment, I might make it very small, so don't worry. We have almost covered 3/4 of the job, so we are done. Next, after a small break, maybe, I don't know how